We turn our attention to Objective 7, which is about binary molecular compounds. When nonmetals hook together, we include our prefixes in the name. Say the name of the first element, the last one ending with "ide," and attach the prefixes to let us know how many of each. Counting chemistry style. With our first example, Cl5O2. Prefix for 5 is penta, attached directly to the element's name, chlorine. Pentachlorine. Last, we'll end with an IDE, attaching the prefix directly to its name, dioxide. Pentachlorine dioxide. The second example reads N7O. Prefix here for 7 is hepta, attached directly to the element's name, nitrogen. The number 1 must be included in the last name. We get monoxide. Heptanitrogen monoxide. B4Cl6. The prefix for 4 is tetra. The name of the element is boron. Tetraboron. The prefix for 6 is hexa, attached directly to the element with an IDE ending, hexachloride. Tetraboron hexachloride. In the opposite direction, Objective 8, hearing the prefixes and let those guide you to write formulas for binary molecular compounds. Number 1 reads trisulfur pentaoxide. Tri is the prefix for 3. We'll have 3 sulfurs. Penta is the prefix for 5. We'll have 5 oxygens. S3O5. Carbon heptahydride. Carbon with the prefix of mono. It's not written, but we know it's there. There's 1 carbon. The prefix hepta is the number 7, and this element hydride is how we say hydrogen, who's a nonmetal, when he's written last. Hydrogen, written with an IDE ending, becomes hydride. CH7, carbon heptahydride. Octanitrogen trifluoride. Octa is the prefix for 8. We have 8 nitrogens. Trifluoride. The prefix tri represents 3. There's 3 fluorines. And 8F3. The world of binary molecular. Listen to the prefixes and let that guide your subscripts. I'll also discuss acids in this video, Objective 9. Acids are compounds who start with H, and we determine the name of the acid based on the negative ion it hooks to. The first one, I'm going to go ahead and write the original endings in the box. It's the letter P. It's coming from the element phosphorus. It carries a -3 charge from our periodic table. P is a -3. So the name of this monoatomic ion is phosphide. Hear the IDE ending. Group of atoms acting as a unit carrying a charge is called a polyatomic ion. CrO4 -2 is called chromate. I'll record that here. Here's another group of atoms acting as a unit carrying a charge. I'll find its name on the polyatomic ion chart. ClO negative. ClO negative is hypochlorite. Let's put that down. Hooking together hydrogen first, negative ion last, and consider charges. H is a +1, P is a -3. Crisscross, and our formula to create an electrically neutral compound, H3P. The rule here for ide, we're going to say hydro, root word, ic. Phosphide, the IDE, hydro, root word, ic. We come up with hydrophosphoric acid. putting that syllable back into the element phosphorus becomes hydrophosphoric acid, H3P. Chromate is a -2, attaching it to the first name of hydrogen, who's a +1, crisscrossing to create an electrically neutral compound, H2CrO4. Acid rule says 8 turns to ic, and we'll find chromic acid. The last one is a polyatomic called hypochlorite. H is a +1 attached to the polyatomic -1. We simply get HClO. Ite turns to us, says the acid rule. Hypochlorite becomes hypochlorous acid. Hydrophosphoric, chromic, hypochlorous acids. Acids always start with an H that carry a +1. Remember to consider charges.